This is the walkthrough video for PCTC 2023, question 6, crop to content. So we're given this input, which we're told is meant to represent a picture, and we're given all of this white space, all of these dots, sorry, that represent excess white space, or the frame of the picture. And we essentially just want to chop out all of these excess rows and columns of just plain white dots around the picture, so that we get the picture itself. So let's just do the very easy part, which is inputting. So let's say so it's a square, so this is just the side length, 17 in this case. So that's going to be our very first input. Side equals int input. And now let's create our picture list. And for I in range, whatever our side length is, we're going to input something. And we're going to just append that to picture. And that should be fine, actually. Yeah, so like all we've done here is we've taken the side length input, which is in this case 17, and then we've taken 17 rows of this picture, and we've just appended each of those rows as a string to our list called picture. And that's the easy bit. So now the hard bit, which is to figure out how on earth do we chop out all of these top rows, all of these bottom rows, all of these left columns, all of these right columns. So let's just start off with one at a time, essentially. So how do we chop out these top rows? Well, we need to figure out where the rows start becoming useful, right? So we're going to keep seeing whole rows of dots until we eventually see a whole row that is not dots. And as soon as we see a whole row that is not dots, that's when we know our picture started. And so that's like the coordinate of interest. And so let's just code that bit now. So let's go through for every row in range len picture, or I guess that's just going to be whatever our side input was. And we're going to say if picture row, so if the row we're currently at dot count dots does not equal side. So what this conditional statement does is it basically checks if it's a full row of dots, because it basically gets the correct row that we want. It counts how many dots there are, and if there aren't as many dots as the side length or the initial number we inputted, if there aren't as many dots as that number, then we know we've reached a real picture row, right? Because all of these rows, these three rows, each have 17 dots, but this row does not have 17 dots, and that's where our picture actually begins. And so that's what our if statement checks for. So once we've found a real row, let's actually just break out of this for loop because we found the row. And before we do that, let's keep track of where we started off at. So it's going to be start row is going to be equal to row. And row doesn't actually make sense. Let's just call that I, because it's not actually a row, it's the index of the row. Okay. So all of a sudden, we've kind of done a quarter of the work, right? We figured out where our image starts off at, and that's useful because that means later on, we'll know that we should chop off those top three rows. Okay, now let's figure out which row does our image end on. And this is the harder part, because if we were just to go down the list or down the image until we found a row of 17 dots again, well, then we're going to reach this row. That row has 17 dots, but you can tell the image is not yet done, right? Because there are still valid rows after that row of 17 dots. And so the way to do this is to go from the bottom to the top. Because as we go from the bottom to the top, the second we encounter a non-17 dot row, then our picture is almost like started, but started from the bottom. So that's where our picture ends. So you can almost think of it like where we've got our picture and we're scanning from the top and from the bottom until we encounter the rows that finally contain not just dots. And so that's going to happen here, which we've already coded, and it's also going to happen here, which we're about to code now. And that's pretty much the same code as we did up there. So let's just copy paste that. But the range this time is different, right? Because we're going from bottom to top and not top to bottom. And so we start off at the side length, -1, because remember, Python's 0 indexes. So we always need to do the -1. We end at 0, and so let's go one further, that's -1. And we go in increments of -1. And so this range, it'll just go from bottom to top, essentially. It'll go from index 16 to index 15 to index 14 to index 13 and so on. And that should be it. And let's change start row to end row, because now we've saved, so basically after these two for loops, we've now saved the starting row number and the ending row number of our actual image. And now we need to do the exact same thing, but for the columns. So what's the starting column and what's the ending column? Now you can try and think through the logic and think through the indices we should be looking at and all of that stuff. But there's a faster way to do this, right? We've already written these two for loops. So you might as well reuse those for loops. But how can we really reuse a row for loop to look at the columns? Well, we can transpose our picture. And so to transpose our picture in Python, we do this, like that. And so what transposing does is it just swaps out the rows and the columns, right? It's almost like a rotation of our grid. And so since we've swapped the rows and columns, the rows right now are actually what the columns originally were. And that means we can straight up just copy paste all of the code we've just written and apply that. And let's just change this so it makes a bit more sense. Let's say start column and end column. But of course, now our picture is just rotated, right? Our picture is not the actual picture. And so to turn it back into the actual picture, we can transpose it again after doing all of that. And that's like pretty much done. We've got our starting row, we've got our ending row, we've got our starting column, and we've got our ending column, and we've got the actual picture itself. And so now we have to modify the picture to extract and print off just the picture itself. So just to recap, what we've done so far is we've scanned from the top of, we scan the rows from the top until we find an image. We scan the rows from the bottom until we find an image. Then we've rotated our entire image and done the same thing again. And since we've rotated it, we're actually dealing with columns this time. And then to make sure our image is back to what it should be, we just rotate it again. And that puts it back to where the right columns and the right rows are. And so now with the printing bit, let's say that's going to be for row in, I guess, for, yeah, it's not row, it's the index. So for I in range, and what's our starting row? Our starting row is start row, that we calculated earlier. What's our ending row? Our ending row is end row. But because this is Python, we need to add one there. Because the ending row is this row. So it's going to be the index of whatever that line is. But because it's the range in Python, we need to find the index of that line, and we go up to, but not including that line. And so that's why we just add the end row plus 1. And we would just be able to print, for example, that row just by doing that. But then, of course, we haven't chopped out the left and right. We haven't chopped out the columns. And so just chop out the columns. Let's take that row and let us only, let's slice it. So we slice it from the starting column. And again, we slice it to the end column plus 1. Let's make that a bit clearer, just like that. And that's actually not going to get us full marks, because that's not going to work, because actually that should work, shouldn't it? No, yeah, it's not going to work, because why isn't that going to work? Picture. Let's do some live debugging. So it's good to see some live debugging. Start column 2. I mean, that feels like it would work. So what's the output show? So the output, okay, oh yeah, okay. So the output is still in our like tuple format. And the reason it's in a tuple, so we've never actually turned it into a tuple, right? Because up here, we just appended the strings. But when we transposed the picture, it turns the strings into tuples, or tuples, however you pronounce that. So let's just kind of unpack them there. And to make sure we don't add, so by doing this, we add spaces between each of the elements in the tuple. And so if I were to show the outputs, it shows the correct image, but it adds spaces between each of those characters. And so to remove those spaces, let's add the sep parameter and make that equal to nothing. And so we should be able to submit that code and get those 10 points. And I would say, yeah, keep in mind this transpose trick, right? Because whenever you've got a grid and you need to do the same thing to the rows and the columns, if you've already written all of the logic for the rows, you might as well just copy paste the exact same code for the columns. And to make sure that works, you just transpose it. Make sure you transpose it before and after to make sure you readjust it back to its original position.